Hello everyone, welcome to my channel Math Text by Dhruti. This is a series of sessions for differentiation and currently we are discussing chain rule for differentiation. This is the second session for chain rule, so if you have not attended the first session, please find the link in the description box. So today we are taking some examples. Let me take the first example. Suppose we are given y is equal to sine of x square plus 1. So first of all, we have to understand that which is the outer function and which is the inner function. So here sine is the outer function and x square plus 1 is the inner function. Okay, so when we are differentiating this composite function, we need to apply chain rule, and in that process the outer function will be differentiated first and then the inner function will be differentiated, right? So sine is differentiated first because it is the outer function. So derivative of sine is cos. So cos, derivative of sine is cos. So sine x square plus 1 is cos x square plus 1, and these x square plus 1, that means the inner function is differentiated separately. So that is equal to cos x square plus 1, and here it is addition rule. So x square, derivative of x square is 2x plus 1 is constant, so it will be 0. And therefore the final answer is 2x cos x square plus 1. So this is my answer. Let us take one more example. Suppose it is given that y is equal to square root of 10x. So which is the outer function here? First of all, is square root of 10x a composite function? Is it a combination of two or more functions? Any idea? Okay. So let us see how square root of 10x is made. So suppose I have a function f of x is equal to root x and another function g of x is equal to 10x. Okay, then when I'm taking f of g of x, see f of g is a composite function, f of gx, g will be worked on x and then f will work. So f of g of x is nothing but f of gx, so that is equal to f of my gx is 10x, and the definition of f says whatever is inserted, it will give output as the square root of the input. So right now it is 10x is inserted here, so output will be square root of 10x, right, which is our function. So f is the outer function and g is the inner function. What is f? F is the square root and g is 10, and therefore the square root is the outer function. Okay, the square root is differentiated first. Now what is the derivative of square root? So d by dx of square root of something is 1 upon 2 root of that value. Okay, here in the place of dot anything might be there. We have right now 10x. So dy by dx is equal to this square root is differentiated using this formula. So square root of 10x is 1 upon 2 root 10x into the inner function which is g10 is differentiated separately, and the derivative of 10 is sec square, and therefore the answer is sec square x upon 2 root 10x. Okay guys, let us take one more example. Suppose I am given that y is equal to cos raised to 5x, which is the outer function. Cos raised to 5x, which is the outer function. The power 5 is the outer function. See, suppose I have a function fx is equal to x raised to 5 and gx is equal to cos x, and if I combine these two functions FOG, that is f of gx, that is f of gx is cos x, and definition of 5 says whatever is inserted, it will give the fifth power of that input, right? So this is equal to cos raised to 5x, which is our function. Hence, the outer function is the power 5, the inner function is cos, right? So fifth power is differentiated. So how to differentiate a power? The power is differentiated and whatever the inner function is raised to n minus 1, right now I have cos here, so it will be cos raised to n, so n cos n minus 1, n is 5. So let us see how it is done. Cos raised to 5 dot raised to n dot raised to n minus 1, so it is 5 cos raised to 5 minus 1 is 4x into the inner function g, which is cos x, differentiated separately. And the derivative of cos, we know that it is minus sign. So 5 cos raised to 4x into minus sin x, and I rewrite this expression as minus 5 cos raised to 4x into sin x. This is my answer. So what we have understood is whenever square root of the some function is there, the square root is the outer function, right? When there is some power of a function, that power is the outer function. This is what we have to remember, guys. Okay, I hope you have understood this. In next session we will encounter some more difficult examples, so please make sure that you attend all the sessions. Goodbye, take care.